We already seen the divisibility rules for 2 to 5 in the previous video. If you have not watched, go back and watch that video. I'll leave the link in the description below. So now let's look at divisibility rules for 6 to 10. So let's take 6. The condition for 6 is any number, any given number should be divisible by both 2 and 3. Both 2 and 3. Let's take an example, 561. So for me the best thing is, for the divisibility rule, you already know for 3 you need to add all the digits and sum them. Sum of all the digits should be divisible by 3. So if I sum it, what happens? 5 plus 6 is 11. 5 plus 6 plus 1, that's 12. 12 is divisible by 3. So that means this number is divisible by 3. But is that divisible by 2? No, not divisible by 2. So that means this whole number is not divisible by 6. If you ask me, the first thing you can check is just by looking at the number, because we know for 2 it's easy, even you don't need to add all of them. If the unit digit ends with 0, 2, 4, 6, 8, you can just straight away say it's not divisible by 3. So if it is not divisible by either one of this, you can straight away say it's not divisible by 6. So the best thing to do is go for 2. Then if it is divisible by 2, then do this calculation and see whether it's divisible by 3. Then you can say it will be divisible by 6 or not. So let's take one more example, 993. 993, looking at the unit digit, it's not divisible by 2, but it is actually divisible by 3. But what happens is, just because I've already checked it's not divisible by 2, so I can straight away say it is not divisible by 6. Simple. So let's go to 7. Little bit complicated, but might be difficult, but just let's look at it. 7. There is a rule for this. It's not straightforward like 6 or even 5 or 10. So let's look at it. Let me take a number, 763. The condition is, if you take unit digit or the last digit from this number, from the right hand side, first digit, double it. Double the unit digit. If I double it, what's going to happen? I'll get 3 plus 3 equals to 6. Now whatever number is left, which is 76, subtract that. 76, that is 6 there, 6, which is 70. Subtract that. So I can actually even go further, but I can actually see from this is divisible by 7. 7 ones are 7 tens are. So that means 763 is divisible by 7. 7 ones are, then 7 nines are. So as you can see, it is divisible by 7 and gives us remainder 0. Let's take another number, 5913. Little bit bigger number, 5913. I have to double this. If I double this, 3 plus 3 is going to give me 6. I need to subtract that from here. So that will give me 585. So now again you continue the same process. That is 5, double it, 5 plus 5 is going to give me 10. So I don't need to take that digit. I'm going to subtract that by 10. Get 48. As you can see, this is not divisible by 7 already. 7 sevens are 49, so we need one more. So that means this entire number is not divisible by 7. Let's take one more, because this is one where you need to actually do it either in your mind or otherwise just on paper, but try to understand exactly how I'm doing it. 9120. What happens? 0, if I double it, it's still 0. So if I subtract from that, not from that, that is not included, I'll still get 912. So now I double this 2, that becomes 4. I don't need to include that. 91 minus 4 is 87. Is 87 divisible by 7? As you can see from that table, 11 sevens or 7 11s are 77. Then after that it goes 84. So that means this number is also not divisible by 7. This is not divisible by 7. So we doubled this, subtracted, we got the same number, we doubled it, subtracted 87. The other way you can also do it is, if I actually double it, that will be 7 7 14. So I have to subtract. If I subtract, what happens here? 6. What 6 is this? Because negative number is larger, so it will be next. Doesn't matter. Sorry, in any of this you can also encounter negative, but main thing is, are you able to divide that by 7 or not? I will not be able to divide. As we saw here, what happens? 7 11s are 77, and another 7 which is going to 84, and 3 will be left. So anyhow you will be left with some remainder. So this number is not divisible by 7. Let's move on to 8. 8 is simple. So if I take 8, any number 1 2 3 4, last 3 digits should be divisible by 8. Then the whole number, this whole number is divisible by 8. So if I take 234 divided by 8, 8 ones are 8 threes are, then 0, but still I'll be left with 3 remainder. So this number is not divisible by 8. So let's take one more number, 9035, some number, doesn't matter, but this will be easy. It's not divisible by. Let's take 5963. Okay, here let's divide this by 8, last 3 digits from this end. 8 ones are 16, 1 is left, 8 2 is a 16, again 2, 3 will be left, so also not divisible by 8. So condition is, you just take last 3 digits, try to divide it by 8. If it is divisible by, then the whole number, no matter however long is larger is the number, the whole number is divisible by 8. Let's move on to 9th. 9. So the condition is same exactly as number 3. Sum of all digits should be divisible by 9. So 1 3 4 5, 5 4 9, 1 plus 3 plus 4 plus 5, 5 plus 4 is 9, 12 and 13. 13 is not divisible by 9. So that means this whole number is not divisible by 9. Let's take 9051. What happens? 9 plus 5 is 14, plus 1 is 15. Again not divisible by 9. If the same thing was 9054, what would have happened? 9 plus 5, actually 9 plus 0 plus 5 plus 4, any of 0, nothing is there. 9 plus 5 is 14, 14 plus 4 is 18, 18 is divisible by 9. So that means this whole number is divisible by 9. 9054 divided by 9, 9 ones are 9, 0 9 6 54, it's 106, so it's divisible by 9. Let's go to 10th. 10. So what do we have with 10? So 10, the only simple condition is the last digit or unit digit must be 0. any number. You take 1 5 9 6 3 1. No, not divisible by 10. 5 6 9 8 0. Yes, divisible. 590 divisible. 391 not divisible. Simple. Only looking at the last digit you can say whether it's divisible by 9 or 10 or not. So these are the rules for 6 to